In lesson 3, we're looking at probability. Probability is the chance of something occurring. So it's the chance that something happens. So why is this important? Well, for example, if you buy a raffle ticket, there are some things that you would need to know in order to know how good your chances are of winning. So if you buy a raffle ticket, what do you need to know to estimate your chances of winning? Well, one of the things you would need to know is how many tickets are sold. If you bought one raffle ticket and I told you that I only sold 5 raffle tickets, well, you might think, okay, well, 1 out of 5, that's not too bad. But if you bought 1 ticket and I told you that I sold 1,000 tickets, then you're feeling like your chances aren't quite as good. The other thing that's important to account for is how many tickets you bought. You don't have to just buy 1 ticket. How many tickets you bought. The third question you would need to know is if every ticket has an equal chance to win. If every ticket has an equal chance to win. All right, let's look at an example. There are 22 students in the class, and each student buys 1 ticket. Your chance of winning is going to be 1 out of 22. So notice the top number is telling me the number of ways I can win. The bottom is telling me the total, right? I have 1 winning ticket potentially out of 22 sold tickets. Another way that I could write this is 1 in 22. So how can I write this as a percent? Well, to take any fraction and turn it to a percent, you're going to multiply by 100. So you're going to take your calculator, you're going to do 1 divided by 22 equals times 100. And we're going to round to 2 decimal places. So you're going to look at the third number always to help you decide what to do with the second number. This is going to end up being 4.55%. Okay? So if you think about what you saw in your calculator to start, you had 4.5454, so on and so on. You're looking at the third number to help you decide what to do with the second number. Since that third number is 5 or more, the second number is going to bump up. All right, example 3, determine the probability of rolling a 6-sided die, so there's 6 total outcomes, and getting each outcome. Okay, so we want to know the probability that we get a 4. So remember there's 6 in total. The total number of outcomes always goes on the bottom, so at a 6. How many 4s are there on a 6-sided die? Well, a 6-sided die has 6 sides. The number 1 is on one side, then there's a 2, a 3, a 4, a 5, or a 6. So out of those 6 outcomes, only one of them is a 4. So I have a 1 out of 6 chance. If I want to write it as a percent, 1 divided by 6 times 100 is 16.67%. B, a 4 or a 5. So out of those 6 outcomes that we listed below, let's erase the circle on the 4. Now I need a 4 or a 5. So which numbers are going to fit with that? Well, there's 2 numbers out of the 6 numbers that fit. So 2 out of 6, or you can change it to a percent. 2 divided by 6 times 100 is 33.33%. All right. C, a number greater than 2. All right, so again, we have 6 numbers in total. Let's go back to our list. Greater than 2 does not mean including 2. So if it said 2 or greater, that would be different. So 3 fits, 4 fits, 5 fits, and 6 fits. So there's 4 numbers out of 6 that fit. Again, if you change it to a percent, 4 divided by 6 times 100 is 66.67%. Some of these fractions can also be reduced. For example, 2 over 6, I could divide both the top and bottom by 2. So I could also write that as 1 over 3. 4 out of 6, I could divide both the top and bottom by 2. So I could also write that as 2 over 3. Those all mean the same thing. So this is called theoretical probability. Theoretical probability is the likelihood that something happens without actually conducting an experiment or a survey or a study. So it's what should happen in an ideal world, right? If you flip a die, ideally 1 out of 6 times it should land on a 4. Now, is that going to always happen? Not necessarily, but that is what is called theoretical probability. We can express probability as a fraction, as a decimal, or as a percent. All right, and as a ratio. Example 4, the letters of the word manager are put in a hat. Determine the probability of drawing a P of M. So this is just another way of saying probability of getting an M. So if you look at the word manager, there are 7 letters in total. Okay, A wants to know the probability of getting an M. So out of those 7 letters, how many are M's? Just 1. So that would be our fraction. If we want to write it as a decimal, we would just do 1 divided by 7, and we would get 0.14, rounding to 2 decimal places. Or if we want to write it as a percent, we would do 1 divided by 7 times 100, rounding to 2 decimals, we get 14.29%. Make sure that whenever you're going to a percent, you go from the fraction. So you do 1 divided by 7 times 100. Technically, you could look at the decimal of 0.14 and times that by 100, but that would give you 14%, and you'd be missing some of those extra decimals. So whenever we're going to a percent, we always like to go from the fraction that we're given, not the decimal, because we've already rounded that decimal. Let's look at B, probability of A. So again, there's 7 letters. When you look at the word manager, there are 2 A's, so 2 out of 7. If you want to write this as a decimal, you're doing 2 divided by 7. You get 0.285, so on and so on. So we're going to round to 2 decimals, which is 0.29. Or 2 divided by 7 times 100, rounded to 2 decimals, is 28.57%. All right, the probability of a vowel. So out of the 7 letters, let's take a peek at what we have as vowels. A and E. Remember, your vowels are A, E, I, O, U. We only have 2 A's and an E here, so that's 3 letters out of 7. 3 divided by 7, rounded to 2 decimals, is 0.43. 3 divided by 7 times 100, rounded to 2 decimals, is 42.86%. Okay, let's look at example 5. You are a town planner and you need to know if people want walking trails or bike paths along a river. You survey 1,500 people who live in the town. Identify the population. So the population is the people who live in the town. The people who live in the town. As a result of the survey, suppose 60% of the people prefer bike paths. Determine how many people. So you're given a percentage of people and you want to turn that into a number. So you are wanting to find 60% of the total 1,500 people. So the first thing we're going to do is we're going to take 60% and we're going to turn it into a decimal. So there's 2 ways to do that. We're just going to do 60 divided by 100. We could turn it to a fraction. Or 60 divided by 100 is 0.60. The trick is you could take 60% and turn it to a decimal just by moving the decimal 2 places to the left. We're now going to take the total number of people. We're going to times it by 60% as a decimal. So that means there are 900 people who want bike paths. C. Determine how many people do not want bike paths. Well, if there were 1,500 people in total, 900 of them want bike paths. How many are left that don't? We're going to subtract the 900 that want. Whatever's left over, which in this case is 600, 600 people do not want bike paths. So the number of people that want something and don't want something have to add up to that total of 1,500. What assumptions are you making? Well, in this case, we're assuming that people either want a bike path or a walking trail, but maybe some people want neither, or maybe some people want both, and we haven't accounted for that. Okay, so what assumptions are you making? That everyone wants one of the two options. That everyone wants one of the two options. Some people could want neither. And some might want both, but that wasn't an option to answer for both. All right, last page. Example 6, Ruth surveyed all the grade 12 students in 2 high schools to determine their eye color. A total of 900 students were surveyed. The results were as followed. 656 have brown eyes, 83 have blue, 115 have green, and 46 have other. From her results, predict how many first-year students at the University of Winnipeg from a population of 9,700 might have brown eyes. So what do we already know about the chances of brown eyes? Well, we know the chances of brown eyes of grade 12 students. We know that out of 900 grade 12 students, so our total goes on the bottom, 656 will have brown eyes. So this is our probability of brown eyes. If we want to transfer that information to predict out of a different number of students, all we do is take this fraction and times it by the new number of students, which at the University of Winnipeg is 9,700. So we're going to take our calculator, 656 divided by 900 times 9,700, 7,070 people. Okay. What assumptions are you making? Well, what we're doing is we're taking information about grade 12 students and we're using it to make a prediction of first-year university students. So what assumptions we're making here is that all the same students from the grade 12 survey would then go to U of W and be the same in order to be able to predict those results. So what assumptions are we making? That all the same students would go to U of W, and the probability would be the same. That's why it's called a prediction, because we can't say for sure. We can just base it on the data that we already have. All right. Example 7. A youth group has 400 members, so this will be our total, and offers 4 activities. It conducts a survey to determine each member's preferred activities, and here are the results between swimming, rock climbing, movies, and bowling. Without knowing their answers, so ignoring the data that we have, what is the theoretical probability that they prefer bowling? So theoretical probability is not based on data. So all we know is that there is a total of 4 activities: swimming, rock climbing, movies, and bowling. We want to know the probability they prefer bowling. Out of the 4 activities, how many are bowling? Just one of them. So 1 out of 4, or 0.25 as a decimal, or 25%. What is the actual probability? So now we are using the fact that we know how many people out of 400 like to bowl. So if you look at the numbers, that's 71 out of 400. 71 divided by 400, rounded to 2 decimals, is 0.18. 71 divided by 400 times 100, rounded to 2 decimals, is 17.75%. It's really important to understand the difference between the theoretical probability and the actual probability. We call this the experimental probability because it's based on data. Okay, one is just using the fact that there's 4 activities and one of them's bowling, and the other is actually using collected data. Which answer best reflects the member's preference for bowling? That would be B, the actual answer. They were surveyed and could give an actual opinion. So it's based on their opinion. They were surveyed and could give their opinion. And that's the end of lesson 3, and that's also the end of our statistics and probability unit.